Hello, my name is Mary, and this is my science fair project, Dangerous Deodorants. You might be wondering how deodorant could be dangerous, and they can be because some deodorants contain high levels of TVOCs. But what are TVOCs? The definition is total volatile organic compounds. But what are those? First of all, the adjective volatile is defined as liable to change rapidly and unpredictably, usually for the worst. Organic compounds are compounds that contain carbon atoms. Some elements that combine often with carbon are hydrogen, oxygen, and nitrogen. TVOCs are a measurement to report chemical compounds in air or emissions emitted into the air. For example, formaldehyde is the type of VOC that I tested in my experiment. TVOCs have high vapor pressure and low water solubility. It is important to be aware of the TVOCs around you, like in the deodorant you should be wearing. My research problem is that you need to wear deodorant, but not every chemical and cosmetics are safe for you. So my test was to determine if there is any deodorants with safe levels of TVOCs. So I tested a variety of different brands. My research question was, at regular body temperature, 37 degrees Celsius, which deodorant will have the lowest levels of TVOCs after 30 minutes? My hypothesis was that the deodorants that were cheaper and did not look natural would have higher levels of TVOCs. The labels were also a bit of the reason I chose the way I did. From highest to lowest levels of TVOCs, my hypothesis was Lady Speedstick, Ban, Degree, Dove, Nivea, Jason, and Attitude. For my procedure, first of all, I had to set up the chamber, which included building it and cleaning it, and preheating the temperature to 37 degrees Celsius. Next, we had to weigh out the deodorant and place it in a dish inside the chamber. I'll spin it around to represent the deodorant on an armpit. We put that in the chamber with the TVOC testimeter, which uses a laser to check the surroundings for particles in the air. The next step was to check and record the TVOCs after 30 minutes. Then we had to repeat that test multiple times, 7 times, to get each deodorant tested. In my results, my hypothesis turned out to be partly correct. I thought that the more expensive and natural deodorants would give off less TVOCs. I hypothesized that the Attitude brand deodorant would give off the least, which it did. But the one I thought would give off the most, the Lady Speedstick brand, was actually in the middle. What surprised me the most was the Nivea brand deodorant, which I thought would be the Nivea and the Jason brand deodorant, which I thought would be some of the better ones. They were actually the worst by a lot. In the results, you can see after we checked the deodorants at 5 minutes, 15 minutes, and 30 minutes, the Nivea brand was the worst and the Attitude was the best throughout each test. We also checked the pH of deodorants to see which ones were the closest to your regular skin pH. We found out that the Attitude brand was very similar to was very close to the regular skin pH, and the Nivea brand was way off, which was really basic. One of the things I would have done differently in my further experimentation would be to run multiple tests, which I did not do because I had many variables I needed to control so I could trust my results were accurate. Some of the variables were the temperature of the chamber, which I controlled with a thermostatic heating mat, the air quality, which I controlled with a HEPA filter, and the weight of the deodorant, which I could have weighed to 1/10 of a gram instead of 1/1000 of a gram. Another thing I could do would be to test the better deodorants to see if they actually work.
Hello, my name is Acacia Nielson, and I'm in 7th grade. Orange juice can be nutritious and delicious. In this experiment, I investigated one nutritional aspect of orange juice: vitamin C. My research question is, what type of orange juice contains the highest levels of vitamin C? Is it bottled orange juice, frozen orange juice from concentrate, or freshly squeezed orange juice? Now, what is vitamin C? Vitamin C, also known as L-ascorbic acid, is a water-soluble nutrient that aids the body in collagen production, immune system health, bone, tissue, and cartilage strength, as well as iron absorption. Now, after you see my title, you might be wondering, what is titration? Now, the definition of titration is the determination of the concentration of some substance in a solution by slowly adding measured amounts of some other substance, normally using a burette, until a reaction is shown to be complete, for instance, by the change in color of an indicator. So my hypothesis is, after researching the orange juice processing methods, I think that the freshly squeezed will contain the most amounts of vitamin C. Secondly, I think the frozen from concentrate will contain the next highest value of vitamin C because of minimum handling and refining. And finally, I think premium bought from the store will contain the least amount of vitamin C. My variables are my independent variable, which is the type of orange juice, and the dependent variable is the vitamin C content. Now for my procedure. First, I had to start by making 3 types of solutions. I had to make a starch indicator solution using starch and distilled water. I made an iodine solution using iodine and distilled water. And I made a vitamin C standard solution using these vitamin C tablets dissolved in distilled water. Now, the way this works is I'll pour iodine into my burette. Now, I can measure how much iodine I am starting with, measuring from the bottom of the meniscus, which is the curved line that goes below the water. So once I fill my iodine up to at least 12, I can say, okay, I have 12 milliliters of iodine in my burette. Then I will take my iodimer flask and add my starch indicator solution and a known amount of vitamin C solution. Then I will put it under and turn the burette knob, slowly letting the iodine drop out. After about 7 to 15 milliliters, you will see instant color change within one of the drops. That is when the orange juice or vitamin C has titrated. When it's titrated, it will look this color. Then I will measure how much iodine I had to add for it to titrate or change color. So then I can figure out how much iodine I had to add to titrate the vitamin C that I know how much there is, the known amount of vitamin C, and I can see how much iodine I had to add to an unknown variable, aka my orange juices. Now you can see more about the problem I used to figure this out in the data analysis. So after repeating the steps twice for each type of orange juice, I came out with my results. Now you might be wondering why I only did 2 tests for each of my oranges. My original plan was to do 3 tests, but after doing 2 tests of each of the kinds, the results were so consistent and similar, there is no need to do a 3rd test. So in the end, here are my graphs from lowest to highest. My hypothesis was proven correct. These were the premium bottled, which had the lowest amounts of vitamin C. Next, it was the frozen from concentrate, and the first place was the freshly squeezed. Right here you can also see charts with averages and each of the individuals all put together. Now for instance, if we were to say that the fresh squeeze was 100% vitamin C, which is just a speculation, or it's just a made-up number, but to put that into perspective with the rest of the numbers, the frozen concentrate would be 65%, the Uncle Max, which is my first type of bottled, would be 59% vitamin C, and the Trader Joe's bottled premium would be 52%. So looking at these 2 numbers, 52% and 100%, the fresh squeezed almost has twice as much vitamin C. So in conclusion, the vitamin C content in the different types of orange juice proved my hypothesis correct. The difference between bottled, frozen, concentrate, and fresh squeeze was surprisingly drastic. I would like to thank my parents so much for helping me with this experiment, and I would like to try the experiment again using different types of oranges versus freshly picked versus bought from the store, or seeing if the vitamin C changes if your box of orange juice has sat in the fridge for a week. So overall, I really enjoyed this experiment, and I hope that you will walk away with a better understanding of vitamin C in orange juice. Thank you.
Hello from Canada. I'm Finn.
And I'm Jude.
We're homeschool buddies from Peterborough County, Ontario.
We both love drones, and we both happen to have the same one.
So we decided to do our science project on, surprise, drones!
We did some background research on drones and read up on some concepts pertaining to our experiment. Hey Finn, what's a drone?
Well, Jude, a drone is a remote-controlled pilotless aircraft or missile. You might also be interested to know that a quadcopter is an unmanned helicopter having 4 rotors.
Another term we needed to define is battery life, which is the length of time a device can continue to work before it needs its battery to be recharged.
Lift is the upward force exerted by the air on an airfoil or other structure. According to Newton's third law, air must exert an equal and opposite force on the airfoil, which is lift.
Thank you, Finn. We also reminded each other about the definitions of weight.
The force experienced by a body as a result of the Earth's gravitational pull.
Gravity.
The force that attracts a body toward the center of the Earth or toward any other physical body having mass.
Mass.
The quantity of matter an object contains.
And motor.
A thing that imparts motion.
We wanted to see how weight affects the battery life of a drone. The purpose of our experiment is to identify how much weight you can transport for how long and what the optimal battery size for the drone is.
Our hypothesis is that for every percent added of weight, there will be the same percent decrease in time of battery life.
The materials we used are
2 drones,
drone batteries and chargers,
loonies, a lot of them,
including us,
Scotch tape,
kitchen scale and notebooks and pencils,
stopwatches on our mom's phones,
a wide open room for plenty of space to fly our drones.
Side note, we usually fly our drones outdoors, but we decided to do this experiment inside so we could control the variable of wind and temperature and random birds.
Gotta watch out for those Canadian geese. We weighed the drones and made sure our drone batteries were fully charged.
We timed the drone flights and recorded them and then fully charged the drones again.
We taped 1 loony to each drone and weighed the drones. Then we flew the drones and timed their flights.
We repeated this flight 3 times and charged the drones in between each flight period.
We repeated the process, adding 1 more loony each time, doing 3 flights of each weight.
It took us about a month to complete all of these flights. Of course, we recorded all of our data along the way.
So here are Finn's results.
I flew 15 flights. 3 flights with no additional weight, and the average flight time was about 1,069 seconds. 3 flights with 1 loony and an average time of 1,062 seconds. 3 flights with 2 loonies and an average flight time of 995 seconds. Average flight times of 946 seconds for 3 loonies, 940 seconds for 4 loonies, 955 seconds for 5 loonies, 940 seconds for 6 loonies, 923 seconds for 7 loonies. Each loony weighed about 6 grams, and so for every gram added to the drone, the flight time seems to decrease by 3.5 seconds, assuming that it's a linear decrease. And here are Jude's results.
I flew 16 flights, 4 flights with no additional weight, and the average flight time was about 844 seconds. 3 flights with 1 loony and an average time of about 807 seconds. 3 flights with 2 loonies with an average time of 827 seconds. 3 flights with 3 loonies and an average of 725 seconds. And 2 flights with 4 loonies and an average time of 682 seconds. Each loony weighed about 7 grams, and so for every gram added to the drone, the flight time seems to decrease by 5.5 seconds.
There are many variables that are uncontrolled, like the battery life, the piloting, and various environmental factors. Evidence of this is that the drone flight times are very different from each other, and the results are inconsistent.
However, on average, every gram of weight added to the drone decreased the battery life by between 3.3 seconds for Finn's drone
and 5.5 seconds for Jude's drone. Our batteries were rated at 1900 milliamp hours, and Jude's weighed 45 grams.
And Finn's weighed 46 grams. If you use this and our average flight time data, we estimate that each additional gram of battery and casing will add about 16.5 seconds of flight time.
So we need more battery, more power!
In conclusion, we were partially right on our hypothesis that there is a linear relationship between weight and flight time, but we didn't have the numbers right.
If we had to do this experiment again, we'd do many more flights of each weight to get better data.
We also need to figure out a better way to make the weight stable on the drone and not change the center of gravity.
We are now going to try and wire 2 of our batteries together and see how that goes. Bye!
Hello, my name is Logan Shafer. I am from Waco, Texas. My project investigated whether chess ratings had deflated, meaning that chess players are playing stronger than their rating. Many people in the chess community have been speculating that ratings are deflated. Although there has been abundant speculation, I could not find any research studying the topic of rating deflation by measuring the accuracy of players' games, so I decided to do it. I decided upon and tested 3 rating groups, 500 to 1000, 1001 to 1500, and 1501 to 2000 over 3 time periods, 2015, 2019, and 2023, from the online chess playing platform, Lichess. I used G-Power statistics software to calculate the total sample size of games I would need for my results to be reliable, which was 84 games per rating group, 252 per year, and 756 for the entire experiment. My hypothesis was that, over time, chess players in the specified rating groups will increase their average computer aggregated precision scores, demonstrating rating deflation. To test this hypothesis, I downloaded games from the Lichess database from the month of August of the 3 specified time periods and used random.org to randomly select each game. I then used Skid vs. PC to read and copy the PGN and pasted it into chess.com's CAPS calculator and individually recorded each game's CAPS score into an Excel spreadsheet. To analyze the data I gathered, I used SPSS to run an analysis of variance test. The results showed that the only significant change in CAPS score was between the years 2015 and 2019 in the 500 to 1000 rating category, meaning my hypothesis was only supported for one rating group. A possible reason for this could be that there have been an abundance of new resources out between the years 2015 and 2019, which have helped aid in the improvement of newer players. Future testing could be done by measuring games played over the board in tournaments rather than online, or measuring games from another online platform. Thank you.
Hi, my name is Grace Lavan, and my project is Meet the New Neighbor: Can Gray Wolves Establish Territories in Areas of Higher Human and Road Density Than Expected? Gray wolves once lived throughout Minnesota, but because of unregulated hunting, their numbers dropped to around 500 animals. They were placed under the Endangered Species Act, and the population grew, and wolf ranches expanded from northern Minnesota into southern Minnesota into where my study area is, around the Duluth area. There was a study conducted by Fuller in 1992, and he found that 88% of wolf packs live in areas of human and road density below 4 humans per square kilometer and 0.7 kilometers of road per square kilometer. I conducted this study to see if that has changed since 1992, and if it is different in the Cloquet-Duluth area as shown in my study area map here. My question was, will wolves establish territories in areas of higher human and road density than expected, comparing my results to Fuller's results. My hypothesis was that wolves can establish territories in northeastern Minnesota in areas of higher human and road density than expected. I worked with a wildlife biologist from the Fond du Lac Resource Management Division who volunteered to share wolf location data with me, as well as road data which he got from the Minnesota Department of Transportation. Excuse me. I uploaded my data into ArcGIS Online to draw wolf territories. I drew territories around clustered wolf location points. Wolf packs, like the battery wolf pack, gave me some difficulty because they didn't have necessarily one area where their points were clustered, so I kind of had to give an educated guess of where they're spending a lot of time. As you can see, he kind of went out on some side expeditions. He was all over the place, so drawing his territory is very difficult for me. I imported the wolf territories from ArcGIS Online into ArcGIS Pro to create maps with census block data from the ArcGIS Online Living Atlas, as well as the road data shared with me by my mentor. I measured the kilometers of roads in wolf territories to find the road density in wolf territories. Some wolves use border roads for their territories, so bordering roads are considered roads that wolves don't cross very often that border their territories that are within 0.5 kilometers of their territories. So the Woody Road Wolf had 2 very clear borders, which were Highway 2 and Highway 33. I included those roads in the sum of the length of roads for wolf territories. So I divided the sum of the length of the roads in kilometers and divided that by the area of the territory in square kilometers to find my road density. To find the human density in wolf territories, I used a select by location tool in ArcGIS Pro, which found all of the census blocks within the wolf territory. I also included census blocks that were at least halfway within the wolf territory, and I found the total human population in the wolf territory and divided that by the area of the territory in square kilometers to find my human density. I uploaded those densities into Google Sheets to create my graphs. The wildlife biologist I worked with also shared wolf weight data with me, so I could assess if wolves are still alive and living in territories with higher human and road densities than Fuller's threshold, or if those wolves had died and what they died from. Like if they were living in areas with higher human density and died because of humans, or if they were living in areas of higher road density and were hit by a car. The maps created in the study will help biologists get a better understanding of if human and road density in wolf territories has a correlation with wolf pack success, so if wolves are raising more than one pup in a litter, or if those wolves are living in the territory for more than 1 year, and if wolves will establish territories in areas of higher human and road density than expected. I created my graphs in Google Sheets. So figure 1 shows road density in wolf territories. I found that 6 out of the 12 wolf packs I studied exceeded Fuller's threshold of 0.7 kilometers of road per square kilometer. The graph is color-coded by wolf weights. So red shows wolves that were illegally killed, blue shows wolves that were legally killed, black shows the wolf that was killed because of an automobile, green shows the wolves that was still alive at the time that I created my graphs, brown shows wolves that died of natural causes, and gray shows wolves whose fate we don't know about, so their color fell off and we can't track them anymore, so we're not really sure where they're at. As you can see just from the graph, the woody road wolf who died because of a car did not live in a territory with road density above Fuller's threshold, showing that Fuller's threshold of human or road density doesn't necessarily mean that that is going to be the cause of wolf fate. So living in an area of higher road density doesn't necessarily mean that the wolf is going to die because of an automobile. Figure 2 shows human population density in wolf territories. Just like Figure 1, 6 out of the 12 wolf packs I studied exceeded Fuller's threshold of 4 humans per square kilometer. 4 of those wolf packs exceeded both the human and road density thresholds in wolf territories. To restate my hypothesis, I said that wolves can establish territories in areas of higher human and road density than expected. My hypothesis was supported. On average, wolves live in areas with 6.67 humans per square kilometer, which is 2.67 humans per square kilometer greater than Fuller's results. I also found that on average, road density in wolf territories was 0.77 kilometers of road per square kilometer, which is 0.07 kilometers of road per square kilometer greater than Fuller's results. This may be because wolf population has risen to the point where there's not as many areas that are below Fuller's thresholds for wolves to live in, so they might not have a choice but to live in areas of higher human and road density than he found in his study in 1992. Wolves will also use roads to make travel easier, so cleared roads are just easier for wolves to travel on than it is to travel through the woods when there's 2 feet of snow. Wolves will also scavenge roadkill, which might be another reason why they're hanging around roads more. Deer are the major prey of wolves, so wherever the deer go, wolves are probably going to follow. So if deer are near to human populations, to find bird seed or some people even feed deer, then the wolves will also follow those deer and end up being closer. I found that 2 of the 4 packs who exceeded both of Fuller's road and human density thresholds raised successful litters. The other 2 packs I did not have litter data for, but for the 2 packs I did know about, they both raised at least 1 pup successfully for 2 years. This shows that wolves can have successful litters while living in areas with higher human and road density than expected. This information will benefit wolf management agencies like the Fond du Lac Resource Management Division, just by giving them the information that wolves can live in areas of higher human and road density than expected, and that they can live there successfully, meaning that there's more of Minnesota that's inhabitable for wolves, so wolf range can continue to expand, wolf numbers can continue to rise. They are still placed under the Endangered Species Act. They are still protected species in Minnesota, so knowing that humans and wolves can live together well is important knowledge for wolf management agencies.
Hello, my name is Janae, and today I will be doing a presentation on the effects of different liquids on plant growth. The inspiration for this experiment was from a few years ago, when some of my potted plants had begun to turn yellow and wilt. Not knowing what was wrong with them, I decided to use olive oil on the leaves and soil as a supplement for the fertilizer, because I knew that olive oil contained a lot of the nutrients, which I later learned was vitamin K and E, that were essential for healthy plant growth. I was still very surprised when within a few days, the plant's leaves began to turn greener, and they were back to their original health by the next week. I was also interested in wanting to test the sugar water for this experiment because of the positive effect on cut flowers and the way it stimulates the natural sugars which are transported by the plant's phloem cells. To understand this process, I did some background research. Because of the waxy substance on the outside of their stem, plants have no way to absorb water but through their roots. But how does liquid from the roots get to where it is needed in the leaves and stalk? This is where xylem and phloem cells come in. Xylem and phloem cells are small bundles of vessels in a plant that carry liquid up and down the length of the stem. Xylem cells carry water, while phloem cells carry a liquid with a type of sugar called sucrose in its tubes. These cells use a process called transpiration, similar to how we breathe in and out, to transport the liquids throughout the plant. From my research question, I came up with my hypothesis. If seedlings were watered with different liquid mixtures, then out of sugar water, light olive oil water, extra virgin olive oil water, and tap water, the sugar water mixture would produce the fastest germinating and healthiest seedlings. Here's a list of my materials. I used the small spray bottles to water my plants with, and the calendar and notebook to document my results. My procedure was fill the egg cartons with soil and plant 3 to 5 seeds in each cup. After labeling them with popsicle sticks, place them in a small greenhouse with heating mat and grow light. Water seeds thoroughly on the first day with tap water. Make specialty water by mixing 79 milliliters of water with equal parts of olive oil and extra virgin olive oil in separate spray bottles, and 38 grams of sugar dissolved in 79 milliliters of water in another bottle. Alternate between this specialty water and tap water for the next 9 days. After 9 days, use regular water exclusively for the next month. For my results, the light oil mixture did not do all that well. Although they started off healthy, they were smaller and slower growing than all the other plants and eventually turned black, very oily, and then end up rotting. The extra virgin olive oil plants were fast growing and kept up with the tap water seedlings as far as health. 9 sprouted 4 days after they were planted, but about a week after, some of them started to turn black and soon shriveled within the next couple of days. The sugar water mixture did not do well at all and never germinated. The soil was rock hard every morning before they were watered and hard again by the evening. Above all, the water plants did the best in height and health. 21 of them sprouted 4 days after planting. They were a little gangly when they got taller, but were a really pretty green color. Here's a comparison of my tap water and EVO seedlings. As you can see, the EVO plants are much oilier and darker than the tap water leaves. This graph shows my results with the tap water plants obviously surpassing all the other ones. The EVO plants did pretty well up until about day 5, where they plummeted and shriveled until there was nothing left on day 8. The light oil plants were okay, but around day 5 started to rot, as is shown with the thinning of the green line. After seeing the results from my first experiment, I decided to try it again and revise my hypothesis. If the seedlings were watered with an EVO water mixture twice a week and tap water the rest of the time, then they would be stronger and have a faster germination rate than the seedlings watered with only tap water. I followed the previous procedure for the EVO mixture and tap water, but only used tap water every day instead of every other day, added EVO water mixture twice a week, and used half a teaspoon of EVO mixture instead of pouring it on. The reason I did not continue with the sugar water trials was because after I had done some online research, I had found that sugar water is one of the worst liquids to water plants with because 1. Crystallization, 2. It attracts lots of bugs, and 3. It can collect bacteria. So it was decided it was better not to continue and just reset with the EVO trial. The results were very surprising. Even though the new EVO seeds were planted 2 weeks after the tap waters, new seeds grew at a rate 4 times faster, sprouting out of the soil in a record of just 24 hours after planting. By the end of the first week, they were almost the same height as the 3.5-week-old water seedlings, as well as being stronger, greener, and more drought tolerant. And drought tolerant meaning if I watered later in the day instead of in the morning like usual, the EVO plants were still stronger and firmer, whereas the tap water plants were beginning to wilt. And I did do this same experiment on zinnias, kale, broccoli, and gourd to see if I would get the same results. And the EVO all produced seedlings that grew faster and taller than the seedlings watered with only tap water. And I also contacted the county's extension agency, and he did warn against using EVO on plants, but I did have the same caution, which is why I ended up changing my hypothesis. And here's a graph that shows the information for their new results as well. As you can see, by week 4 of the EVO plants, they are almost a whole centimeter taller than the 6-week-old tap water seedlings. One thought I had about why the seeds with the EVO mixture sprouted sooner is that if water expands the seed coat to break open the seed, then it would make sense that the oil would break it open faster because it is denser than water, so the seed would most likely need less oil than it would water to crack open the seed. I also talked to the manager of my local nursery, and she thought that maybe the oil helped retain moisture in the soil better than the water did. In conclusion, the results did not support my first hypothesis that the sugar-water mixture would be the best liquid to water seedlings with. Even though the first results on the graph showed that tap water had the best growth rate, the second graph showed that extra virgin olive oil seedlings took off and far surpassed the water plants in height and germination. This supported my second hypothesis. As you can see, the amount used and frequency of the watering all affects how the plant grows. More experiments with more types of plants and longer observation from germination to maturity would add additional support to confirm my hypothesis. These results could also prove useful for farmers and nurseries who would be looking to speed up plant growth for earlier crop and plant sales. Thank you for listening to my presentation. Bye!